So there are two types of mainly equations are there. Basically simple, or you can say complex, compound, anything you can say. Okay, so I will explain. So basically, why do you need this proposition logic or this true false? Okay, so we know that the computer understands only one or zero. Okay, so if you want to tell this, if you want to quote that 2 plus 3 is equal to 5, so computer have to know whether it is a right or wrong sentence. Okay, true or false. So how to implement that thing into a computer, that can be achieved by this uh, propositional logic. Okay, so let's, we can say this propositional logic can be divided on the basis of syntax or semantic. Okay. Semantics is, you can say, atomic or complex. I'll tell you what this is. Atomic, you can say, or simple, you can say, or you can say single. Okay. So some of the things I have, you have found actually these things, or this complex we can use this by negation. Okay, negation. Okay, so what is negation? So today is Monday. Okay, so what will be the negation of that? Today is not Monday. So if today is Monday is the sentence. Today is Monday.
এখন আর পার
So let us consider this sentence as a P. Okay. So negation is denoted by this symbol. Okay. Okay. This negation symbol. Sorry. Okay. So this is negation. So today is Monday. So we can denote this by using P. Okay. So what is the negation of P? So negation of B is will be today is not Monday. Is not Monday. So that is negation. Then we have disjunction. Okay. What is disjunction? Or we can call this as a or operator. Okay. Or operator. Okay. So or means you should eat or watch TV at a time. That that sentence is called as, we are using or, that's why it is called disjunction. So you should eat or watch TV at a time. Okay. And what is the conjunction? Conjunction, or we can say and operator. Let's say today everybody said that please share and subscribe. Okay, this is a common phrase. Subscribe. So this is an example of conjunction. So we are saying please share also and subscribe also. Subscribe the channel. Okay. So this is called conjunction, and there are two more are there. Two more complex these symbols are there. This is one is called. These are called connectives. Okay, these are called connectives. I forget to mention. These complex proposition logics are connected by these connectives. That's why they are called connective. Okay, if then. Okay, then if and only if. If and only if. Okay, I will explain these two later. Okay, first let's go into these three deeper. Okay, so let's consider some example. So do you know truth table? I think everybody heard of this truth table. Okay. So basically, what is conjunction? Conjunction, that two proposition can be combined by the word and, okay, to form a compound sentence. Okay, you can write that down. Any two proposition. Okay, I'll write it down. Any two. Just tell me if I am visible or not. Okay. Any two proposition can be combined by the word and. Okay, so that's why it's called AND operator. Okay, to form a compound proposition. Okay. Okay, any two proposition can be combined by the word and to form a compound proposition. Okay, said to be conjunction. Okay, so what is the truth table of this and? Okay, so let us consider two sentences P and Q. Okay, these are let's say variable or sentence, you can consider anything. Okay, so P and Q. So what will be the truth table of P and Q? Okay, so I will tell you. So you have to make a truth table, na? So how many elements are there? I mean, we have taken two sentences, no? So always the number of variable. Okay, 2 to the power number of variable. If you want to make truth table of 3, then 2 to the power 3. If you want to make the truth table of 4 variable, then 2 to the power 4. So 2 to the power 3, 8, 2 to the power 4, 4, and 2 to the power 4 is 16. So basically, if we have two variable, then we need four input. Okay, so either this can be true or this can be true. Okay, or this can be true or this can be false, or this can be false or this can be true, or this can be false or this can be false. Okay, these are the only possible combination. Okay, or in case of, let's say we have another variable pqr. Okay, then we will have eight combination. Okay, just like this four. Okay, so I will just talk about this two variable only. So if true in variable, always remember the symbol multiplication. In case of P and Q, just remember the multiplication. And if we consider, because we know that in computer true is denoted by 1 and F is denoted by 0. So if you forget, okay, if you forgot that what will be the output, so just multiply this. So 1 into 1, so it will be 1. So it will, the answer will be true, that is 1. Okay, okay, then true, then false. So 1 into F, 1 into 0. So 1 into 0 will be 0. Okay, so then F into T, again 1 into 0, 0. Then what will be the last one? Okay, what will be the last one? 0, obviously 0 into 0, F. Okay, so that is an example of conjunction truth table. Okay, so this is basic truth table for conjunction. Okay, we'll go deeper. So I am explaining a bit slow because some of you might from background might not have maths or this kind of thing, so I am going straight. Okay, so example, I'll tell you some examples. So in sentence, Delhi is in India, and 2 plus 2 is equal to 4. So what will be this? This sentence is true, okay, and this sentence is also true. So true and true, here you can see, here you can say true and true is equal to true. This sentence is true. So output will be true or 1. 1 or true, same thing, okay, 1 or 2, same thing. So then let us consider another sentence. Delhi is in India, and plus 2 is equal to 5. So this sentence is true. Okay, this sentence is true. And this sentence is false. So 1 into 0. So it will be false. Okay, because any of the two sentences, if one is false, then the result will be false. Okay. So let's go to the next. Okay, that is okay. Disjunction. Okay. So this is for conjunction or and. Okay. Now we'll go to disjunction. Disjunction or or. This is the or operator. So let us consider again two value P and Q. So you can make this conjunction table or truth table for like say uh, 2 sentence, 3 sentence, 4 sentence, okay, or you can say variable. You can say we have done it for 2 variable P and Q. You can do it for PQR, PQRS, like that, many variables. Okay, so try to do that. Okay, in your free time. So P and Q. So P and Q. Okay. So in here, just remember in here we have remembered multiplication. Just here remember addition. Addition. Okay. So this is 1, 2 true, 2 false, and false true, then false false. Okay. For true you just consider 1, for false consider 0. So 2. 1 plus 1 is equal to 2. So actually that for that case you just consider it a positive or 0. Okay, or in binary 1 plus 1 you can that consider. I will not go into binary. Okay, so 2 plus 2, so 1. Okay, true and false, 1 plus 0, 1. So it will be, result will be 1. So here false into true, that is 0 plus 1, 1. So it is 1. So basically these are all true. This is 0 0. So it will be 0, or you can say it's false. Okay. So this is the truth table for disjunction or. Okay. So I hope you understand this. And now, okay, I'll give an example. Okay, just like last time. So example, let's say example, same example you can take. Delhi, Delhi is in India, or 2 plus 2 is equal to 5. Okay, so here you just see this sentence is true. Okay, this sentence is true, or you can say 1. Here this is wrong, that is false. So you can denote as 0. So 1 plus 0 is equal to 1. So answer will be true. So in disjunction, any one of the input is true, then the answer will be true. Okay. So here this Delhi, if the both input are wrong, then it will be false. If the both the input are false, then the answer is false. So here you can see that Delhi is in Russia. That is also false. And 2 plus 2 is equal to 5. That is also false. So answer will be false. So this is called disjunction. Okay. So okay. Now we'll see what is tautology. Tautology or contradiction. Okay. Contradiction. What is tautology or contradiction? Okay. So does anyone know what is tautology and contradiction? Okay, if you don't know, that is also fine. So see here, in the right side, the result side, okay, not all are true. Okay, you can say this is false. False, zero, same thing. Okay, not a problem. So, but if you write one, then write one, one, or if you write true, false, then only in result side write false or true. Okay, don't mix those two notation actually. Okay, so in here, if a statement does not agree with the statement contradiction, yes, it's correct, but I will explain here. Okay, mathematically. Okay, so in here, so tautology means if the right column, okay, this third column, if the all the value of the this result is true.
No.
Let's say, let's consider, okay, this is true, this is true, this is true, this is true. Okay, that is called tautology if the all output are true. If not, if any of the one are wrong, then it is called contradiction. Okay, so basically what are you saying? This is fine. Okay, but we are explaining through truth table. Okay, so I will tell you one example. So well, sometimes this type of questions come up. Okay, so I will tell. So I will give you expression. So P. Okay, so I have forgot about the truth table of negation. Sorry, before telling about tautology and contradiction. So P. Okay, so what will be the this truth table of negation of P? Either this or you can you can use both the symbol. Okay, you can use both the symbol. So truth table of this P is P. Okay. So if it is true, then the negation of P will be false. And if P is equal to false, then negation of P will be true. Okay, negation of P will be true. So now I'll explain you contradiction and tautology. So I'll just so basically, what is the negation? So negation proposition of any given proposition P, let's say P, is the proposition whose truth value is opposite to P. If the truth value of P is truth, then the negation of P will be false. If the truth value of P is false, then the negation of P will be true. Complete opposite. Okay. So next, go to this tautology. Okay. So next photo, what is? So I will give an expression. I will give you an expression. P. This is or. Okay. negation of q, and negation of p, negation of q, so and q. Okay, so this is an expression. So we have to calculate the output of this expression. We have to calculate the truth table. Okay, so let's see. Okay, so first I will write this down. So how many inputs are there? Two, P, P and Q. Okay, P and Q. So input will be 4. Okay, so how many rows will be there? Actually 4. If the variable size is 3, then 2 to the power 3, 8. Okay, so just remember that. So now let's see. Okay, P, Q. Okay, then negation of P, negation of Q, then this term we will consider P, negation of Q, then second statement we will consider negation of P, negation of Q. Okay, so PQ value. So what will be the value? True, 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 false, false, true. So false, false. So now we have to find out. So the question is, so is the following expression, is the following expression is the following expression and tautology, a tautology. Okay. So with truth table. Okay. So with truth table. So this is the question. So we have to find out whether this expression is a tautology. So let's see this P and Q. So these are the inputs. Okay, either it is true, true, false, false, true, and false, false. These are the only input possible. This is the combination that are possible. So negation of P. So just rotate. So right inverse of P, actually that is true opposite F, true opposite F, false opposite true, then false opposite true. Okay. So for that similarly write for Q. Q is equal to false. False is equal to true. True is equal to false. And false is equal to true. Okay. So up to this point, no problem. So now just consider P or Q. Okay, negation of Q. So we have to take this column and this column. Okay, and we have the connective or. So this is true, this is false. So if it is or, then remember and sorry, if it is or, then remember addition. Okay, remember addition. So 1 f, so 1 plus 0 is equal to 1, so that is true. Okay, similarly true, then false, then similarly true, then false and false. 0 plus 0, so it will be false. Similarly ft, so ft 0 1, 0 plus 1 1, so basically we will write true. Okay, so similarly if you want to calculate between these two, negation of p is this one. For second expression, negation of p, false false true true. Okay, and negation of q, false true false true, these two. is true. Okay, negation of P and negation of Q. So false, false. So what will be the result? We have OR. So 0 plus 0, 0. So it will be false. So false plus true, I mean 0 plus 1 is equal to 1. So that is true. For similarly, 2 plus false, then 1 plus 0 is equal to 1. So that is true. 1 plus 1, that is I have told earlier, true. So these are the results of these two expression, one and this. So finally we have to calculate as a whole this expression. Okay, so I'll write this. Okay, this is the expression. So between we have to compare and now we have to compare and this is the and symbol, and these are the two expression. This expression is this one, sorry, this expression is this one, and this expression is this one. So we have to use and between them. And means multiplication. Okay, so true, false, false. That is, what will be that? False. 2 into true, 1 into 1, 2. False into true, false. Then true into true, that is also true. Is it fine or is it wrong? It is okay. Let's just see.
Yes, sir.
Okay, now we have to again, we are not completed yet. Okay, so we have to again compare with Q by operator or. So let's take this expression. So let's try to, I'll try to write here. Okay, okay, I'll write this expression as a x. Okay, I'll, for conventional purpose I will write this expression as x or q. Okay, x or q. So x is nothing but this expression, this whole expression. This is with I am denoting as x. Okay, x or q. So false, true, false, true. This expression I have written this. Okay, ft. So what is the q value? You see here, tf, tf, tf. Okay, so basically we are doing or truth table. Okay, so we are doing or f and t. So basically or means addition. 2 plus false, I mean to say 0 plus 1, 1. True plus false means 1 plus 0 is equal to 1. Similarly, all value will be 1. So basically all will be true. So now you see the right side of the truth table. Okay, right, the right, the utmost right side of this expression. Okay, the of the truth table, all the value will be true, or that is we can call it as 1. Okay, true or 1, same thing. But if you write false true, don't write 1 here. Okay, if you write 1 and 0, then write 1. Okay, for I am just, for explaining purpose, I am just writing like this. Okay, now all the values are true. So what that means? So this is basically a tautology. Okay, so because all the values of the right side is t, all are true. So I will give you a homework. Okay, so I will give you an expression. Okay, just wait. I'll give you a question. So P, okay, so that the proposition P and P are equivalent. Okay, can you somebody explain the question? Okay, so actually what I'm saying, so these will give some output. Okay, this truth table will give some output, and this expression will also give a output. Okay, so both the output of the right side will be similar, equivalent. So we have to prove that. Okay, just try to do that. This thing. Okay, I will. I will also give a or question. So, 3, determine whether the following expression of equation, you just write anything. Equation is contradiction or a tautology. So just remember, tautology means T is there, na? So this is true. So truth, all values should be truth, and contradiction any one value of the truth table of the right side. If it is false, then it is contradiction. Okay. So I'll give you the expression P U U. Okay. Just screenshot or you have to find out this expression whether it is a tautology or it's a contradiction. Okay, so why we are doing in a artificial intelligence class this Boolean algebra, or you can say discrete mathematics. Okay, so this is the basic actually. So you know that uh, algebra basically you can say discrete mathematics 1 and 0. So computer understand only 1 and 0 machine. So you want to input any sentence, whether it is a true sentence or false sentence. So that sentence might be complex. So in order to explain this thing to a computer, so we need discrete mathematics. Yes, what is the second explain of the first question? It is visible. P or negation of Q and R. Okay, that is the first expression. And second expression is P or, this is or operator, negation of Q or negation of R. This is R. Okay.
Sir,
Yes, tell me.
so the value of R should be also taken like the P and Q, right?
Yes, yes. So that so what I am telling now, variable is 3.
Yes, sir.
So how many rows will be there? 8. Because why? 2 to the power 3. So
3.
3 is the number of input. Okay, if I let's consider P Q just for S. Okay, P Q R S. For this truth table, we have 2 to the power 4. that is 16 rows. Okay, 16 possible combinations are there. Okay, just tell me, I want some input. Am I going too slow, or you want me to go a bit fast, or is it fine? Okay, so if you want, tell me. So I want your feedback. Okay, so do you like this, or just you like PPT? Which format you just prefer? Just I'm asking for feedback purpose. This is kind of conventional method. Okay. Okay, both. Okay. Okay. Now, is there any question? Okay, I think. Okay, tell me question. Just ask me.
Sir, these two questions you've given us for the homework, right? To
Yes,
solve.
yes, yes, yes. So you need not to submit tomorrow or like that. I will tell a date. Just write this question. I will tell you as an assignment. Okay. Let's go. Let's say I have given two questions. So tomorrow I might give two questions. Just write this down and try to solve this, and at last try to submit as an assignment. Okay. 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 I will try to use a iPad or something like that. Okay. So basically, okay. Next from the next class, not next class, from the next week, I will try to use the iPad. Okay. Then there will be not a problem. I'll tell you. I'll tell you when to submit. Okay. Okay. Recording. Okay. Actually, I don't think this recording will be available. You can use Bandicam or this kind of software on your site. Okay. Because I don't think so that Google Meet have inbuilt recording option. It might be there, but in earlier version it's not there. Okay. Yes, yes. You have to submit as an assignment, but not now. But not now. I will tell you. Just try to solve it. Then you do not need to waste time for your assignment or these things. If you solve it today, so it will be beneficial for you. So I will make a group. Okay. Next session will be, I think, Wednesday. Okay. Next session will be Wednesday. So I have to finish this preposition logic. Okay. So today almost time is over. So I have to explain you two more conjunction, if and only if, and if then. Okay. These two conjunction are remaining. So I will explain these two in the next class. Okay. So okay, I'll send the photo. Okay, I'll send the photo. Okay. Okay. Thanks from my side. Okay, so I will send you the photos, but try to go through these slides. Okay. Okay, if there any problem, then mail. Okay, last time I think somebody asked some question. Okay, my colleague told me. Yeah, I'll share. Wait. Is it now visible? Okay, so some you might ask the question why these are the deductive reasoning is a propositional logic. Okay, so basically this. So from today's class, it's clear. So deductive means either true or false. Okay. So here you can say premise one: all the human is basis. So this is a true statement. Suraj is a human. True statement. Suraj is basis. It's a true statement. Conclusion is true or might be false. Okay. So that's why it is called propositional logic. It is a type of propositional logic. That's why some of the reasonings are called this propositional logic. And inductive reasoning is a type of propositional logic. Okay. All the reasons we have seen in the Zoom are white. So this is true. Okay. So basically, is it clear?
Sir, can you explain it again? It's
Okay.
quite
Okay. I'll
confusing.
explain just deductive reasoning. So all the human is veggies means all the humans is vegetables. Okay. So basically that is a true statement. Okay. Next statement is premise two. Suresh is a human. So Suresh is a human. So we have given that Suresh is physics is either true or false. Okay. We can explain this. Can say it is true or false or false. So this type of statement is known as propositional logic. If we can say as a true or false statement. Okay. So here with okay. Here you see, if I put my hand in fire, then it will burn. So it might not be there because if I put my hand in fire with some gloves, then it might not burn. Okay. So either it may be true. Okay. It may be true or it may be false at the same time. Same time. Okay. It may be true or it may be false at the same time. So that's why it cannot be said as a propositional logic. But in here you also see cricket implication cricket ground is wet if it is raining. So cricket ground is wet. Conclusion it's raining. It might not be raining. Somebody say drop a bucket of water in the cricket ground or a syntax of water in the cricket ground. Then we cannot say either it is true or it is false. It maybe it is raining, may not be it is raining. Okay. At the same time. So, but in here you see, in here, Suresh is basis. It's only possible is true. Okay, its only possibility is true. Okay, not both at the same time. Did you understand now?
Yes, sir.
Okay, next class. My colleague or I might take. Okay, that we'll decide. Okay, after next Friday, it will be puja. So Friday classes will be not be there. Then we'll again meet at Monday. So Wednesday class will be there, okay, but Friday class might not be there. Okay, I'll take a screenshot of the class. Okay, just wait. Just wait a bit. Okay, thank you everyone then. Bye.